Okay, just to start you off on this. On your warm-up, you want to copy down the two triangles. One of them is nested inside of the bigger one. Okay? Nested triangles are a great tool to use to figure out unknown lengths. So one thing I had mentioned last week is to pull out the nested and make it look like you're comparing two similar triangles. So here's the nested that I'm going to pull out. It's right down here. And I know it's 35 by 30. So now I have the nested pulled out, which now looks like a similar. And I'm just going to highlight the other triangle. And kind of write in bigger print the one dimension that I know. Now from here, you're going to be using scale factor. You've got to figure out that. And then the algorithm, scale factor times the original side equals the new side.
So we write it on the notes. We don't write any of this on the paper.
No, you want to have that and this on your paper.
Okay, but that's it.
Mm-hmm.
Okay.
What are you doing? You're trying to figure out how long the bridge needs to be. And if I'm building a bridge and paying for it, Taylor, I do not want to spend money building a bridge over land. So you got to remember that when you get to finding that missing side link. You're going to have to do something else there. Because I don't want to pay money for this 30 feet right here. Okay, I'm just going to give you a little bit of time to work on that, and then we'll review it here in a sec. All right, so how do I tackle this? Claire? So I got to find the scale factor between the nested triangle that I pulled out and the larger triangle. How do I do that? Kendra?
You do 140 divided by 3.
So how do I know that the 140 should be the numerator and the 35 should be the denominator? Cam, how do I know that this measurement here should be my numerator?
Because it's the new shape?
Yeah. Yeah. This is the shape that has the unknown value. So I know I'm going, if I'm finding that scale factor, I'm going this way, from the known to the unknown. So, and I know that this, and you can code yours because I would like you guys, this side corresponds to that side. I know that this side corresponds to that side. And this side corresponds to that side. So I do that math. This ratio here says that it takes 4 35s to make 140, so I get a scale factor of 4. What's that scale factor mean? Jacob, what does that 4 mean? It's a scale factor of 4 going from here to here, but what does that mean? Someone want to support him? David?
That the scale factor means that it is what you have to multiply 30 by to get the
Okay.
side.
Yep. What else does it mean?
It means how much bigger the new object is.
In length, right? Yeah. That this, if that was 1, this is going to be 4. If this was 1, that's going to be 4, right? So if that's 1, now it's 4. If this is 1, now it's 4. This got 4 times longer than that. And this side got 4 times longer. And then what David said is right. I'm going to take scale factor, multiply it by the original side, and I'm going to get the new side. So here, on my corresponding side is this side, the unknown side. So if I go 4 times 30, I'm going to get 120. Is that how long my bridge should be, Orlando? Why not?
Because it's covering some land.
Yeah, I don't want to waste money building a bridge over land. Especially when Liam, with his nice new haircut, can walk right across that land, no problem. Yeah, man, you look so different. Looks good. So yeah, I'm going to subtract this land piece. So I know that this x is 120, is 120 feet, but that's from here to there. I want to subtract this portion out. And I'm going to get an answer of 90 feet. That is how long my bridge should be. And now Jacob can build us the bridge. Questions about that problem? Finding scale factor using ratios and proportions is a power standard. This is something you need to be good at. And it will be tested quite heavily on the test on Thursday. Okay? So if you struggled with that, come in the morning. Come in, have me help, and I can help you. Okay? I'm coming in about 7:15 every day. I'm here earlier for test days, but I'll be here at 7:15. You can come on in. Or when you get here at 7:30, come on down and ask me questions. But it is a power standard. It's heavily assessed. Remember to pass in your warm-up and exit ticket if you did not. Thursday, I'm done. Whoop, close grades. Whoop, unit done, we move on. So if I don't have it Thursday, it goes in as 0. And I don't want that, but I'm moving on. So warm up and exit tickets. If you didn't pass it into, make sure you get them in. Unit reflections. We're going to do a super fun activity. Should help you a ton. We're going to record it. It's called Fishbowl. Super fun. And then those are due tomorrow. So today should really help you. Unit review is due on Wednesday. I'm already working on a Kahoot for Wednesday night that you can review and do at home. Any questions about any of the announcements? Got a lot going on this week. Trying to wrap things up. Yeah.
Wait, so when's the test?
Thursday.
Okay, cool.
2-part test. Computer portion. Okay, more of the stuff that we do in class. And then you got the paper portion. 2 questions. I can tell you they're pretty tough. Pretty cool. I like them. They are tough questions. I'll be surprised if anyone gets full credit on them. But a lot of you should get at least 60 to 3/4 of it right. There's only 2 difficult parts that we haven't talked a lot about on here. You don't have to do both questions. You get to pick which one.
Oh, are they like extra credit?
No. I don't do extra credit, Lulu. You know that. You know me. I don't do extra credit.
Okay.
I expect you guys to do your best on what you are given. I think that's a pretty fair thing to ask of you because you guys are super sharp and smart. That I don't need to like give you extra credit when you can just do an awesome job the first time. Yeah.
Is one of them easier, or are they one of them easier than the other?
No. They're both pretty difficult.
But like if you were...
They're worth the same amount of points. My feeling is that one might be more appealing than the other, yes, to some kids. And then one might be more appealing than the other to other kids. So that's why I'm giving you a choice. Yeah?
Can you do both?
No. Nice try. That's what she was asking.
I want to.
All right. We'll go over this when we get to the learning for today. But I'm not going to cover that right now. We're going to do Fishbowl. So this is what I'm going to need. We got a good number. I need 4 tables. Axel, David, and Michaela. You guys need to stand up. And you need to put your tables in like a kind of a circle. Okay? We are going to record Fishbowl.
Is it like a grade?
No, but it's to help you do a better job on your reflection.
Or it's supposed to be fun.
It is. It's different. I like it.
Different
Reflections out?
Clara Streeter. Huh? You're going to want a clipboard and your reflection. Nope, tomorrow. Yeah, give me that at the end of class. Was that from last week?
Yeah.
Quickly grab it. Yeah, they are. But I you can see it. You can see it better, and you can show. You can show. Right. They're up there. Clipboards are up there. All right. So the first group that's going to be in the fishbowl is column 1. So if you're in this column, you need to be sitting in the fishbowl. So you're out. Taylor. It'd be, yeah, column 1. That's Orlando, Cam, Maya, and somebody else. We're in no. Everyone should have a clipboard. And your reflection. All right. So I'm going to try to make sure you guys understand how this all works. Let me tilt this down. Because we definitely don't want to miss Liam when he gets up there with his new haircut. Looking good.
Orlando's on.
All right. Okay. So, this is how this works. We're all on the outside. I'm going to give you guys a certain amount of time. and your job is to discuss the question that is on one of the questions, and you guys will be doing number 1. That's on your on your reflection. The way you discuss it, you want to discuss basically the rubric, right? You want to say like, oh, how'd you answer question number 1? We want to use ways to talk. So like if someone shares something, and let's say what they share is slightly inaccurate, you can say things like, hey, I noticed that the way you wrote that is different than how I wrote it, because I thought of it this way. Those are things that you can share to try to help each other out. You can say things like, instead of saying like, oh yeah, I did the same thing, you can say, well, another way I thought about it was this, and share what you thought, because it won't be exactly the same. If you have a question, someone says something and it's confusing, you can say, what do you mean by, okay? I noticed that. I agree. Can you explain more? Or can you further explain? These ways to talk is exactly what Fishbowl is all about. It's practicing discourse as well as conversation around math concepts. On the outside, we're making ours good. We're making our answer as good as we can get it. They're sharing what they know about their answer. At the end of the time, I'll say things that you might have had, that you might have missed. Maybe something I heard that I was like, ooh, that shouldn't be in there. I'll make reference to that. Okay, so don't be afraid to share what you're thinking, because that's going to really solidify your knowledge on that question. All right? The whiteboards are for that. Hey, how did you explain that answer? The whiteboard's for that. You can show that. Okay? Talk nice and loud, because we want the mic to pick up your voices. Okay? And, yeah, just like that, Maya. Just like that. All right. So, fish in the fishbowl. Your question is going to be number 1. I'm going to give you 3 minutes, because part of the grading criteria asks you to restate the question, but fortunate enough on number 1, it's already restated, so you don't have to talk about that. But math vocabulary you will have to talk about. Obviously, sharing how you answered your question and sharing your example are going to be important. Question number 1. If 2 polygons are similar, how can you find the scale factor from one polygon to the other polygon? 3 minutes. Go.
Okay, so when finding the scale factor of 2 similar polygons, you want to get the sides you know, and then divide them so that you get your scale factor.
Yeah, okay, I did. You can do it by finding out how many times bigger or smaller one corresponding side is than the other into shapes. And another way is making the side length of the original, the denominator, and the numerator of a fraction, and that'd be your scale factor. And then you can either leave it as a fraction, or you can make it into a mixed number, or whole number, or whatever.
I put when finding out how many times bigger or smaller something is from the original to the new area of under. I don't make mistakes, but.
Okay.
And then me and Maya work together, so we have the same thing. Yeah, more or less. And then for the example, I did if the side on the original is 3 and the new is 6, then 3 goes on the bottom, 6 goes on the top. 6/3 is equal to 2, and then so 2 would be the scale factor.
Okay, for my example, I said if one side is 3 and the corresponding side is 9, you do 9 divided by 3, which equals 3. 3 is your scale factor.
For my example, their corresponding sides, and 1 is 2, and then the other one is 1, so you do 2 divided by 1, and that's, sorry, I got it mixed up. Okay, so there's one shape that's 1, and then the other one's mysterious, so you don't know it. Then there's 2 other ones, and it's 2 and then 4, so you do 4 divided by 2, and that's 2, so it's 1 and 2. Cool.
For my example, I did 4 times 2 and I got 8, or I got 4 by 6, so I did 4 times 2 equals 8, and then I did 6 times 2, which equals 12.
Okay. Yeah.
Okay, that's about time.
Okay.
So hey, a couple things, suggestions. I thought you answered the question really thorough. Remember in Fishbowl, instead of saying what is on your paper, draw it. Show people.
Oh.
Okay.
Okay? So when you get to the example part, definitely, that's what the whiteboard's there. Okay? Is to show. And then I love how you were talking about denominator, numerator. Okay, because that's an important thing in finding scale factor. Could be 2 key vocab words that you might want to have in your answer. Corresponding was another one. A lot of kids just say, new over original. Well, it's actually corresponding new side over corresponding original side. So that corresponding is an important factor too. Okay, good. Fishies, see you later. Okay, middle column fish, swim on in. All right.
There's too many of us.
Fish in the middle.
There's not 4.
I know, just pull up a chair. You guys are going to be answering this question. If 2 figures are similar, how can you find a missing side length and a missing angle? It's 2 parts. Okay, we're going to go just about 3.5 minutes, starting now.
Okay, first. If 2 figures are similar, if 2 figures are similar, you can find the missing side length by finding the scale factor and multiply it by the corresponding known side length. To find a missing angle, you add up the known angles and subtract it from 180.
So when 2 shapes are similar, you can find the missing side lengths when you find this by finding the scale factor and multiplying it by the original side length. When 2 shapes are similar, you can find the missing angle by adding the 2 angles you have and subtracting it by 180.
So first identify the corresponding sides of these 2 similar triangles and place the first side in the numerator and the corresponding side in the denominator. All triangles add up to 180. So you have the 2 angles, and then you add them together and then subtract it by 180.
If 2 figures are similar, you would use the scale factor, which you would have to find, times the original corresponding side, which would equal the new corresponding side, the unknown side.
I said if 2 figures are similar, you can find the missing angle or length by finding the scale factor and multiplying the original side by the scale factor times the new side.
You're still going?
And to find the angle, you can add up the 2 sides that you already have, and then subtract it from 180, and you'll get your new angle.
I wrote, when two polygons are similar, you find the corresponding sides and divide them by each other to find the scale factor. Then you multiply the scale factor by the corresponding side to find the new side. And what I drew was one triangle one square with a side length of 6 and x for the missing side, so this is the new, and then one with 12 and 12. So to figure out the scale factor, you would divide 12 by 6, which is 2, and then you would divide 12 by 2 to get the new side, which would be 6.
For example, a 1 inch by 2 inch polygon, and a 2 inch by a not known side, you need to find the scale factor. So you divide 2 by 1, and then you get 2, and then you multiply that by the corresponding side to the known, or the corresponding side to the new, the corresponding side, and then you get the new side.
So I explained it, but so if you have like two rectangles and the scale factor is 3, and you're trying to find this side right here, you multiply the original side length 5 by 3, and you'll get your missing side length. And if you're trying to find your missing angle, you take 90 plus 30, and you got 120, and then you take 80 minus 120, and you get 60, and that's your missing angle.
Okay. So you have, you have like these, you have 2, and then you have 4, and then there's a missing side, and you have 8. You find this the scale factor first, and then you like multiply the scale factor of this, like the corresponding side to get your missing side. And then say you have a triangle. One angle says 82 degrees and the other says 55 degrees. Add them both up and you get 137 degrees, and then you subtract 137 degrees by 180, and then you get 43 degrees, and that would be your missing angle.
Okay, I'm going to pause you there. I know you want to go, Jacob. Hey, so listen, it doesn't have to go in a circle. Fishbowl can bounce, and if you feel like 2 people have answered one question really thorough, move on. Ask the question like, hey, let's talk about vocab. What kind of vocab should be in here? Okay, so it doesn't have to be each person's share. It's more about making sure that the fishbowl answers the question the best way possible. Because we never got to like, hey, how would you restate that? Or what's the most important vocab? So it's okay to be like, let's say one person shares their answer, another person shares, and they're dead on, and you feel like, man, we got it. Like, those are 2 good examples. Then when it comes up, be like, I'm going to talk, I'd like to know what vocab we're going to use. So don't feel like it has to go in a circle. Okay? That's just a good lesson there. I loved the drawing on the boards and showing the examples. That's exactly why they're there. Perfect. All right, guys. Great job. Fish, swim, new fish, in.
You have to keep the marker here. Oh, sorry.
Okay. Last question. Last question is, what does the scale factor between 2 similar figures tell you about the side lengths, angles, perimeter, and area?
Really want to start?
James,
Yeah.
anyone can start, honestly.
Okay. This the scale factor between two similar figures will tell us that the perimeter is the scale factor times the perimeter of the original shape. The area is the area of the original squared. The side lengths are the scale factor times the side lengths of the original shape, and the angles are the same as the original.
We don't have to go in a circle, just like no. Do you want to go first?
I said the scale factor tells me that the side lengths will be the other shape sides multiplied by the scale factor, and it would be the same for perimeter, but the angles stay the same, and the area is the scale factor squared times the other shape sides.
Alright, so the scale factor between two similar figures tells us that if one figure has a missing side, the scale factor can be multiplied by the old side to get the missing side. The scale factor can also tell us that the perimeter is whatever the scale factor is, times, lost my train of thought. So it can also tell us that like the perimeter of the original side times, no, sorry. And the scale factor does not affect the angles of the similar figures, because with similar figures, the angles always stay the same. However, the figures change. So if you had a scale factor of 2 or 1/2 going the other way, it wouldn't change the angle. The angles would stay the same between both the similar figures. So yeah. Yes, you're up, James.
We don't have anything. That's the problem here.
Remember, guys, in Fishbowl, you don't have to go around in a circle. Someone can say, so do you have anything to add to that? Right?
Oh.
That's a way to talk.
Also, our vocab.
Okay.
Do you have anything that we should include in our vocab?
Well, we should add like perimeter, side lengths, and angles and all that, because that was part of the question.
Yeah. And we should also restate the question and use similar figures and scale factor. And so yeah. I think that's it. Oh yeah, your example. Show us that.
Okay. So, for example, a triangle ABC has a perimeter of 10. As you can see, 4 plus 4 is 8. 8 plus 2 is 10. An area of 6, side lengths of 4, 4, and 2, and 3 60-degree angles. Then a similar figure with a scale factor of 2 will have a perimeter of 20, an area of 24, side lengths of 8, 8 and a 4, and 3 60-degree angles. So, here are my triangles.
Okay, we're going to pause it right there. So listen, good. I like how you guys got to the vocab part. Part of the vocab that I thought you missed in this question. You need to have squared, because scale factor squared is a huge part of area. So that wasn't mentioned.
I did.
You mentioned it, but I was just saying for vocab, make sure we have it, right? Some of you might have missed that. It is the scale factor squared, and then I can multiply that by the old area, and I get the new area. It's really important. Lulu mentioned it, but it definitely needed to be harped on again because I felt like not a lot of us might have had that. Vocab, I thought you guys nailed it. Good job showing your examples in your work. And the restatement. I really loved how Liam restated his. Because this question's about scale factor and how it impacts those other four. All right, let's put the room back together. Find our seats. Yes. We were just doing a fishbowl. How rude. It's basically a discourse activity. Okay. All right. Yeah, I will. Yeah. Okay. Street or your instruments in the front office, so before you leave school, pick it up. Okay. You can owe me time tomorrow. You know that. All right. Okay. Go ahead, get 4.1 out in front of you. Put those reflections away. What do you guys think of Fishbowl? Yeah? A little bit different, right? It's good. At some point, I'll get better at figuring out how to combine Socratic seminar into my units, but right now I just don't know how to make the time, because I'd love to have a Socratic every unit. I just don't know how to do it yet, but we have time. As you can see, I have to take off 4.4. So, have you guys ever done a Socratic seminar? Oh, they're cool. They're so cool.
What is a Socratic?
It's a way to discuss, but it's more about point of view and supporting an argument. So, today, I'll get that. Oh, thank you, Anthony. Okay, 4.1. Yeah, okay. So, a ratio. We're talking about ratios. That was my I-10 statement. Lulu, 4.1 in front of you. Oh, I didn't see it was upside down. So ratios within similar parallelograms. So a ratio, and I want you to write this down, is a comparison of two. Whoa, that was weird. Of two numbers using division. So my example could be like 8 divided by 2. This is a ratio of how many 2's go into 8. Okay, and of course, I get an answer of 4. But that ratio is a comparison of two numbers using division. 8 over 2. We use ratios for rates. For instance, miles per hour. Okay, that's miles divided by hours. That's what that means. Maybe in Liam's haircut, it is his rate would be hairs cut per second. Okay, that'd be a hard one to calculate. But man, it was good. Next one could be proportions. How much bigger something is compared to something else. Like it's 5 times bigger, 6 times bigger. Okay? A scale factor is a kind of proportion. That's what we've been using our ratios for. And today I'm going to show you how to use ratios to help figure out if objects are similar. So up here, we have two, and we already know they're similar, but I'm going to prove to you that they are using the ratios. We have two figures, C and D. They both have length and width. And I'm going to mark my shape so I know which side corresponds with which side. I know the 8 corresponds with the 4, it's just that the D is rotated. So 8 and 4 correspond, and then I know X and 1 correspond. So I just coded those. So here I go back up to my table, and I have length and width. So my length is 8. Down here my length is 4, because those are the corresponding sides. Then my width, if my width is X on C, my width is 1 on D. And then I'll write those as two ratios. This would be 8 over X, and this would be 4 over 1. What this means, what those ratios mean, is that this is asking me how many X's go into 8? How many widths make the length? How many of these would make this? Here I know I get my answer because I don't have an unknown. I have 4 over 1. I know it takes 4 widths to make 1 length. It takes 4 of those to make that length on that side. So my ratio of 4 over 1 is my length to width. This is what's cool about it. If I know this is a 4 to 1 ratio, and if this is a 4 to 1 ratio, that means figures C and D are similar. If they have the same ratio, Streeter, okay, if they have the same, that means they're similar. Now, I don't know the scale factor, but I do know that they're similar. So, if these are similar, and I have a ratio of 4 to 1, talk to your partner, what would X be then? Go. Okay. So a lot of you guys said X would be 2. That would give me a 4 to 1 ratio. 2 would go into there 4 times. That means for every 2, I'm going to need 4 of those to equal that length. 4 of those to equal that length on that side. So because they are sharing a same ratio, which is 4 to 1, and this is a 4 to 1 ratio, that those two objects are similar and that they have a scale factor. Now, most of us can look at this and see, if I was to compare two corresponding sides, James, this side to this side, what's the scale factor going from D to C? Yep.
It would be like 1/2, 2.
2. Because going this way, it would be 2. Going that way would be a half, right? This would be a half going that way, because 2 is 2 over 1. The reciprocal is 1 over 2.
Yeah.
So the value of X, we decided, was 2. And the scale factor, make sure you write this down. The scale factor is equal to 2. So one thing I want you to understand about ratios within a similar figure is that we're not comparing C to D. We're comparing length to width. And here, length to width. And if that ratio is the same, we have a similar figure. Tomorrow, we will have time to practice this. Right now, in your exit ticket, you're going to practice it. We have triangle A, B, C, and D, and E. We just went over how to use ratios, and that's how I want you to tell me if the objects are similar. I want you to make a ratio of corresponding side. of one side to another side, and then find the corresponding sides and show me how those ratios are equal. Obviously, you're going to have to tell me what the dimensions are in triangle A, B, C, D, and E. And you're going to have to show me how do you know that they are similar. So find two similar figures and explain how you know they are similar. No, they are not all similar. You have to find them. You have to find them using that ratio way. Yes?
Pairs or?
Yeah, you're going to pick you're going to find two similar figures. So obviously, if you look at it, triangle A and C are not similar to each other.
Yeah, we are.
So you would not compare this ratio to that ratio because they're not equal. Remember, your reflection sheet's due tomorrow. So if I said, oh, darn. Then this will take me about 1 minute, and I'll let you guys go. So if I said try C, what would be the ratio there? I think that these two are similar, but I'm not sure yet. So I would do this one. I don't have a value for here, so I have to compare this side to this side. So if I mark that as 1, the corresponding side over here would be 1. If I mark that as 2 down there, then I would mark it. Oh, I did it again. I'd mark this as 2 right here. So this would be 6 over 3. Try would be a 6 over 3, which means that the base is half the height, or it takes 2 of those. And then if I go to try D, I have a 3 over 1/2, which also equals a ratio of 3 over 1.5, which is 2. That means these two would be similar. Later. Bye. Yeah, work hard on those.